Hey, data voyagers. This is Igor Alcantara. This is a quick video just to talk to you about. I thought about doing a text, but I think video would be shorter, would be better. It is very interesting for the ones who are, interested in the math behind neural networks, deep learning, AI, etc. There is a paper that was published. I mean, it's still a preprint. This is the paper here. So scalable math multi-free language modeling. So it's published by researchers from University of California, Santa Cruz. So basically what it says is they were able, again, this is preprint, so there's no peer review yet. So be cautious about the findings. But basically what it says is they were able to train some language modules in a way using a methodology using neural networks, specifically neural networks with multiple hidden layers, which we call deep learning. So basically, large language modules fitted by deep learnings that do not require something we call matrix multiplication. What is that? So matrix, you know, from linear algebra. No, matrices, those like kind of quote tables with numbers. We use those matrices a lot in computer science, in AI, statistics, etc. For example, when I perform my codes that compares simulation tasks, instead of using Levenstein or Jacquard auto methodology, I use cosine similarity, which is basically you calculate the cosine of matrices. So there's a lot of use of matrices, especially in a neural network. So a neural network, thinking about this units called neurons, which are basically functions like program functions, each one of them specialized to calculate something. They connect to one another, do something called the artificial synapses, and then where the logic resides with just the weights of the synapses. And but at the end of the day, with multiple layers, with layer providing part of the information, then we have this beautiful machine learning type of algorithm called neural networks or deep learning, which is basically a more complex neural network with more layers. So part of that processing requires not only matrices, but matrices multiplication. So let's say you have two numbers. You have 2 and you have 7, and then you multiply them. 2 times 7 is 14. That's a simple multiplication. Great. However, matrices multiplication, if you remember, like from class, like from high school, middle school classes, or even linear algebra, when you get them more advanced, they are not as simple. So they are expensive. Expensive in terms of energy consumption and in terms of processing. Consumption of processing time, like GPU, the graphical processing units. That's why NVIDIA it's the most valuable company right now based on the stock market because it produces most of the GPU required for AI. And it consumes a lot of energy because every single thing you process in a computer, it consumes electricity. So that's one of the things. Also, in terms of time, in terms of heating the machine, because you process more, there's more heat provided. So it's expensive. That's why you want to know. Now, why is this related to this study? So they found a methodology. They developed versions of current algorithms that do not, like the transformers, for example, that brilliant paper published in 2017 by Google researchers, and then it's the foundation of all the GPT and Claude, all of those large language models algorithms. So basically, it provided a way to perform those tasks without matrix multiplication. And actually, if you read the paper, there's a lot of math here, so don't get scared about the math. But they got this table, and I'll put it. You don't need to read it on my screen. I'll in the description of the video, I'll put the actual link for the paper so you can download for free. Is again, it's a preprint. Be careful. But they got this table here that shows like the size of the model, like how many parameters it has, the models that they train, and the performance. However, this is a preliminary study. The models that were able to perform with the great accuracy what we called um, a, zero shot accuracy. Basically, is one a module like an AI module, more specific like Gen AI, like language models, image generation, where they can perform a task without being specifically trained on that task specifically. So I might ask them, write me a science paper about, not write me, explain me this science paper, and then I provide the paper, but in a poem form. So it was not never trained to write science in a poem form. However, it can perform. So that's a zero shot accuracy task, basically. So I was able to execute those tasks um, with very great accuracy. However, not as good as like the GPT-4o or even GPT-4, but good enough. And again, this is a preliminary study. Now, other researchers with peer review, they will try to reproduce this study and maybe even go forward and continue on the development of algorithm. To finish this, um, basically the development of AI, basically on three pillars. So we need them to work. They can work separately to some improvement, but the great improvement, we need the three of them. It's basically training. So more training with more data, diverse data will produce better AI models. Um, and second pillar is basically the hardware. So better hardware will produce better AI. And the third is better algorithms. So this is in a way of better algorithms. So not only it's faster, but it's also it consumes less electricity. So it's also more sustainable. And one last thing, even if it does not perform as well as the ones we have, like the popular ones, like, for example, the ChatGPT 4.0 or 4 or GPT-4, has an interesting use case where you can have a pretty good module installed running on small devices like your cell phone or your smartwatch, um, because then they're smaller, they're more electricity dependent, battery dependent actually, because they all depend on electricity. But you always have them plugged in, like you have like server or your laptop. Most of the time, have plugged in. So it might be great for the environment, might be great for AI. I mean, there's other discussions that will take much longer time, maybe with the people in the future discussing like the social impact and environment impact of AI, but there's a different discussion. But anyway, this is an interesting study that I'll like to share with you. And we reaching like we passed like 8 minutes, so I'll finish this again. Links on the description of the video, and make sure you subscribe to the Data Voyagers YouTube channel and bookmark our blog website is datavoyagers.net. And if you're there, also go to LinkedIn, find the page Data Voyagers, and also follow the page. All right. So again, I'm Igor Alcantara. I hope you enjoyed this video. See you next time. Bye.